Hi, welcome back to Simple Programming in Python, where I show simple programming using the Project Euler problems as an example. Let's look at the next Project Euler problem. The idea here is that we will look at the Fibonacci sequence, and they want us to sum all the even value terms in the Fibonacci series. The Fibonacci series is a very famous sequence of numbers, where every number is the sum of the two preceding numbers, starting 1, 2, 3, 5, 8, and so on. You can implement this just that way by calculating every number as the sum of the two preceding numbers, but it becomes extremely slow. I'm still going to do it. I'm still doing it, but it will be so slow. So see this as an example of how not to do it. So very slow fib. If it's the first number, that's 1. Second number, that's 2. If it's another number, then just return the sum of the preceding numbers. Let's try this. We need to time it. So the problem with this is that for every call to this function, we split into two new calls, which in themselves will split into two other calls. Will split into two more calls. So you get like 2, 4, 8, 16, 32. You get a large number of calls even for a small input. But how bad is that? Computers are fast. Let's try this with an input of just 200 and see what happens. Let's indent the comment correctly. Problem 2. So we ran this with 200 as an argument. That's very big for a modern computer, and it's still not finished. So it's very slow. Actually, let's abort it and see if it works better with a smaller number. It can handle 20. It still took 2 milliseconds. 2 milliseconds is a long time for a computer, and that's for a very small input. 40. Apparently not. It explodes somewhere between 20 and 40. We could try 25. Oh, it's 25 milliseconds. So 30, 200 milliseconds. So basically 10 times slower for every 5 I add here. Yeah, 2.5 seconds. And this won't work because we want this function to work all the way up to 4 million. And this was, well, it was close to 4 million, but not to, it's not 4 million. So let's implement this the proper way instead. And the proper way is to go from the beginning. Start with the low numbers and sum them as you go. That way you don't split up, you don't run into any expansion. Instead, you're just calculating. So we do this by keeping track of the previous two numbers. And and we do this n times, because n is the number that passed to us. And actually, I mean, we could use this program to calculate the sum they ask from us, but right now I'm just implementing Fibonacci and showing off the importance of doing things the right way. So previously it took 2.5 seconds, now it took 0 seconds. 2.5, 0. That's quite a bit faster. But the idea was that we were going to sum all those Fibonacci numbers that aren't above 4 million, or the even numbers. So I'm going to do this a third way. I'm going to use a feature in Python called generator. Generator is a function that can return a sequence of return values. So it can return, like first it returns 1, 2, 3, 5, 8, just as the Fibonacci series. But you do this by implementing the function as you would normally, but instead of returning out of it, you use the keyword yield. So every time you call yield, you return one value, but you also keep running. So using the same code as before, just replacing the returns with yield. And now we will get a function or a generator that will generate all the numbers. So let's loop over all the return values from the generator. And try to do the same thing as parenthesis. And I forgot enumerate. So enumerate is a Python function that adds an index to a return value or to a sequence. Every Fibonacci number was paired with its index. And as you see, it's very fast. It's also very fast, not surprisingly, because it's implemented the same way as before. But the idea was that we were going to sum all the even Fibonacci numbers that do not exceed 4 million. Let's just run through all the numbers and sum them into total. Only the even numbers. We can detect even numbers by using modulo operator. If we divide by 2 and the remainder is 0, then it's an even number. And if so, we add it to the total. Let's just clean up a bit. Oh. So, the result is a little bit over 4 million. This was how to calculate and work with the Fibonacci series in Python. I hope you enjoyed this small programming exercise and want to try yourself. You can find a link to Project Euler in the video description, and welcome back for more small programming exercises.